All right, scholars, how are you? Just trying to get the lesson for areas of trapezoids, kites, and rhombuses online for you here. We did a pretty good job in class the other day, considering it was crazy with the pep rally and everything, but I want you to understand where these come from and that you have to know these formulas, and hopefully we're starting to see where 30, 60, 90 triangles and all those come in. Well, the cool thing here is we have our area of our parallelogram, so let's do a quick review, and we know area equals base times height. Notice lowercase letters here. We have the area of the triangle. That's going to be base times height over 2. There's also an equilateral triangle in your notes, but those are the ones you have to know. Now, we also need to know how to use special right triangles. Remember, you need one angle. You need 30, 60, or a 45 degree in a right triangle and one side. Now, here's a number one error people make. They assume, just because we've been using 30, 60, 90, and 45, 45, 90, that automatically means you have that in your diagram. That absolutely does not mean that. Unless you see a 30, 60, or 45 degree angle, it does not assume at all. You cannot do that. So one thing I want to emphasize with this is you still need to know your two triangles. We need our 45, 45, 90, where our legs are the same, x, x, x root 2. Okay, so you know those. Leg, leg, leg times square root of 2 is your hypotenuse. And you also have to know your special right triangle. So my 30, 60, 90 triangle. And then we have our short leg, we have our long leg, which is x root 3, and our hypotenuse, which is based off of the short leg again, which is 2 times x. And remember, our short leg right here is always home base. We use it to calculate all of our other two sides. Then we have our Pythagorean Theorem. The Pythagorean Theorem tells us that we have leg squared plus leg squared equals hypotenuse squared. Or, as a lot of you do, a squared plus b squared equals c squared. And you need to know, remember, you need to know two sides in order to apply it. And also remember, the triples, they will come in handy. All those things are going to help us as we're working with these other formulas. So the first thing is we're going to do the area of a trapezoid. And the cool thing about a trapezoid is we remember the parts first. We have our two bases. They're the parallel sides. You get base 1 and base 2. And our non-parallel sides are called the legs. And just remember, a trapezoid that has congruent legs is called isosceles. And that actually would help you out later. And then I just want you to remember, you've had this formula before. The formula is derived by using a parallelogram again. And it's really 1/2 of a formula of a parallelogram, but that you don't need to understand quite as much as being able to apply the formula. But the formula you've had before is area equals 1/2 the sum of your two bases, don't forget the parentheses, times the height, or, I like this one better, the sum of the bases times the height, all divided by 2. So those are your two formulas, and you need to make sure you really know those. But here's going to be a key thing that you need to remember. You can draw in your height in order to make right triangles. So don't forget, and these would be the same size. So don't forget, your height can be located in many different places on a trapezoid, but we're going to be using right triangles to our advantage. So let's go ahead and start applying our theorem. Right here, they already told you base 1, base 2, and height. So just like before, and it's still going to be required of you on your quiz, is you have to write your formula, you have to show your work, okay, and then you have to give your answer and label correctly. So with this, our area formula is going to be the sum of our two bases times the height over 2. Well, base 1 they tell us is 8, base 2 is 5, our height is 6.2 inches all over 2. So I'm getting out my calculator here because I don't have my cheat sheet here. I don't have my notes all in front of me. So I'm going to sit there and go 13 times 6.2 all over 2. So 13 times 6.2 divided by 2. We get 40.3. Now here's the cool thing. They gave you a decimal. You can answer in decimal, so it's okay. So 40.3, and that would be in square inches. So there is your area formula. Notice how everything stays lined up. Equal signs, where you plug it in. You have to have at least these 3 parts right there in order to get points on your test coming up this week. Now, we have the other one. We're still finding area of trapezoids, but notice we have some issues. Here we have base 1 and base 2. What's missing? That's right, the height. So here's the cool part. Put it in. Now we should be able to somehow use the fact that we just divided and conquered to help us, and this really does in a big way. Because I made this so it's a rectangle, I know opposite sides are congruent because all rectangles are parallelograms. So I know this is 6. So from here to here is 6, but the whole thing is 11, which then implies that this segment right here is 5. Well, that's a leg of a 45, 45, 90. So I move my paper here and do a quick remember when. My two legs are exactly the same size, right? So look what I do down here. Oh look, my two legs are exactly the same size. They're both 5. So my height is 5, and that's just using my 30, 60, 90 triangle. So we plug in our formula. Area equals base 1 plus base 2 times the height all over 2. So we get 6 plus 11, because 11 is the whole second base. Our height is 5 all over 2. So we get on here 17, I would do below, but I don't want to crunch that in too much. Get 17 times 5, which is 85, divided by 2. So 85 over 2, or 42.5 if some of you like it that way, square units is our area. Now we're going to approach the same type of idea for part B, and I know this happens in your book too, but I need to find the height. So I'm going to do the same thing as I did before. I'm going to strategically draw the height in order to make a special right triangle. Or maybe this would be like the Pythagorean Theorem. So I would look for triples, but in this case I notice that's a 60-degree angle, so I can use a 30, 60, 90. But once again, my two bases are 13, and my other base 2 is 19, but 19 goes from here to here. But I made, once again, a rectangle, which is a parallelogram. I know the opposite sides are congruent, so if I've used up 13, what's left here? 6. I should be able to find the height, because now this is my 30, 60, 90 triangle. My short leg, and if you need to put the 30-degree angle in there, that's okay, is 6. How do I go from short leg to long leg? Multiply by root 3. So you get 6 root 3. So there's our height. We're going to put our formula over here. I'll just keep it in blue here. Area equals the sum of our bases times the height over 2. 13 plus 19 times the height of 6 root 3 all over 2. And for some of you, you're going to want to show this step. That's 32 times 6 root 3 over 2. And so you should get 96 root 3 square units is for your area. It's all lined up. All right, we're going to keep practicing and get a new theorem on the next page, and you'll see how easy this is to do.